did B instead of C, so which is fine. I guess I had some questions on that one too. So let me do this one. This is the review questions, and it's number R5C. Okay, it's R5C, and this is the review for. It's actually page 555 too, if that helps at all. And what we have to do here is, just determine something about this graph using Descartes' theorem, the upper bound theorem, but also just what we know about how many zeros it must, positive zeros and negative zeros. I want to do that first, actually. So if I look at the sign changes, look, I have positive, negative, negative, positive, and negative. All right, and this is where I think this is why, Danielle, you asked a question, Daniela, on this, because this is, I don't think this, I'm seeing 3 sign changes here, and the answer key, at least my book and everything, it's saying 2, but that's not right. There's 1, there's 2, and there's 3. So there are 3 sign changes here. So I think that might have been your question, and that might even just answer it right there. But there are 3 sign changes. That means, if I have this chart here, right, I have the positive, the negative, and the complex. I don't know much about the negative yet, but I know for the positive I have 3 sign changes, so I could have 3 possible zeros. That's one possibility, or I could have 1 possible positive zero on the graph. Okay. Now to find the negatives, I'll put it in put negative in for x. So wherever I see an x, I just replace it with a negative x here, right? Negative x cubed minus 8 times negative x squared plus 2 times negative opposite of x minus 5. Okay, so we can see here this is going to be x to the 4th. And then you see the opposite of x cubed is going to be the opposite of x, right? And then times negative 7, that's going to make this plus 7x right here. Okay, the opposite of x squared is going to be x squared, so it's going to be minus 8x squared here. Minus 2x minus 5. And so I can see here, I believe, yeah, there's only just 1 sign change. There's just 1 right there. Do you see that sign change? Okay, so that means that there's only 1 negative. And there's no, I can either have 1 negative or negative 1. You can't have that. So there's no place to go downward from there. So there's only the possibility of 1 negative. And so I can see this as a quartic. It's going to have 4 solutions. So it's either 3, 1, 0 on the complex, or it's 1 positive, 1 negative, and 2 complex like that. All right, so right now I know quite a bit about the graph just from this information right here. But I can also just, the question here was, well, is negative 2 a boundary and is 8 a boundary? And the answer is yes, because, if you put negative 2 in, right, what I get 1, negative 7, negative 8, 2, and negative 5. All right, I think I get alternating signs, and so I know this is going to be a negative boundary, right? I get negative 2, negative 9, positive 18, 10, negative 20, 8, negative 18, and then positive 39, and so what do I get here? Something like that, 34. 34. So when x is negative 2, P of negative 2 is going to be 34, but I can also see that the signs are alternating positive, negative, positive, negative. And so this is going to be a lower bound of the zeros. All right. And now I do the same thing here for 8. Like I said, I've probably already answered Daniela's question, but just because it's kind of fun to analyze and look at, all right? All right, so 8, we put this in right here, and we're going to get, I believe we're going to get all positives with this. So 1, negative 7, negative 8, 2, negative 5, right? Bring down the 1. I get 8, and positive 1, 8, 0, 0, 2, and then 16, and finally I get 11. And so for 8, I get 11 right here. And you can see they're all positive, which I guess I better emphasize here, positive, 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 positive. Since the signs are the same all the way through, 8 is an upper bound. All right, now what does all this mean? Put it all together. What this means, if I go to graph this, and I'm not going to actually plot it all out and graph it, but if I do, I know, let's see, if this is -2 right here, and this is 1, 2, 3, 4, 5, 6, 7, 8. All right. Okay, what this means is I have something like this. I mean, these are the only two possibilities because these give 4 solutions, right? I have to have 4 solutions. It's this fundamental theorem of algebra this is a quartic. It has to have 4 solutions. So it's either going to be this possibility or this one right here. So that means it's going to look something like this. Coming through here, let's see, 3 positive and 1 negative. So that would be what's something like this maybe? 1 negative, 0, and then 3 positive. 1, 2, 3, something like that. Okay, it could look like that. That's a possibility. That would be the first possibility. Okay, and then the second possibility, so let's see. Can I get rid? Yeah. Let's see, the second possibility here, that's 8, would be 1 positive, 1 negative, and 2 complex. So let's see, if I did that, it would be something, maybe something like that. I don't know. You know, well then 8, you know, I didn't check. I mean, 8 is definitely an upper boundary, but if it were this, actually, then 6 would be an upper boundary there. But, you know, something like that. Probably out a little bit more. But see, it's got a real negative, it's got a real positive, and then the other 2 are complex roots. Okay, the last thing I can do here, I think I went ahead and plotted this in Wolfram just to show you. There it really is. Which I know it doesn't quite look like a you know, quartic, but you know, keep in mind it would keep going off over this way. So, and you can see there's the real 0, 0. There's 1 right here. Looks like there's about 1 right here, so there's a positive 1 there and a positive 1 there. So there's actually, I think there's going to be 3. If I could enlarge this right here, there would be a couple zeros right there, and then there's 1 over here. So I'm going to go with it's going to be this is going to actually be what it is right here. It would be interesting to actually go ahead and plot it. Well, you could do it on your calculator too. All right, that's it. All right, hope that helps, and I will talk to you all later.